I'm Ethan Kwan, and today I'm going to be teaching you the definitions of amplitude and period. So, amplitude and period are defined to be things that move, well, this video is about amplitude and period, but amplitude and period are defined by things moving on springs, or things that oscillate back and forth, which means go back and forth. So, for example, if you have a spring with a block here, the amplitude is going to be the distance between the equilibrium point, as it's called. The equilibrium point is the point where it always wants to go back to it. So if you pull it this way, right? If you pull it that way, it's going to want to come back this way. So this is the point at which it wants to come back. And that's called the equilibrium point. So the amplitude is defined to be the distance between the center of the cube and the equilibrium point, which is right there, right? Okay, so that's what the amplitude is. What's the period? The period is the time it takes, for one cycle. So right now, it's stopped, right? And it's going to start going this way. And then it's going to go all the way here and then back, right? And then that's one period. So that is how, one period. And that's the time it takes for one period. That's the period. The time it takes for one complete cycle. Okay, so we know the definition of amplitude because amplitude is defined as how much you pull it back, right? That's just the amplitude, obviously. If there's no friction here, then there's no if there's no friction, then the amplitude is just going to be how much whoever or whatever pulled it back, right? What about the period? What is the period defined by? Well, let's go to a little bit less messy drawing. Okay, so so we have this, right? So if we have this, how do we define the period? Well, maybe the period is based on the amplitude. Maybe how far you pull it back depends on how slow or fast it oscillates back and forth. So some of you might be thinking, wait, so if you pull it back a little bit, it's going to oscillate with a little bit. So if you pull it back farther, it's going to oscillate slower because it's stretched farther, so it's going to go slower, right? Like it's going to slow down and then move slower, right? But some of you might think, wait a second. If you pull it back farther, the spring constant, force of spring equals negative K, the spring constant, M, right? So what about K here? K is, whatever K is, well, if you pull it back farther, there's going to be more K, this is D, sorry. No, it's not B. D, so distance, pulled back. So maybe if you pull it back farther, it goes faster because force is going to be greater, so it's going to go faster. But these two effects, the one that if it goes faster up because if you pull it back farther, the spring pulls harder, and the force that is trying to lower the force, aka the force that if you pull it back twice as much, it's going to go slower. These guys cancel out completely. So the period, the amplitude has no effect on the period whatsoever. Because, well, let's say you take our graph, and let's say you extend it. So what what is the period here? Well, the period is going to be, well, no, the amplitude is going to be how far it goes up and down. Or if this is in meters in the x direction, if this is in meters in the x direction, and this is time, right? So this is x, right? Well, then that means that the amplitude is going to be this length right here, right? Okay, so if we extend the period, or if we extend the amplitude by just stretching, our graph, and if we just stretch it, no, that's not what I wanted to do. If we just stretch it like that and like that, right? It just got stretched, right? That has no effect on the period whatsoever, right? Because the period is going this way, right? It doesn't affect that at all. Because if we extend it like this, it won't matter what this is. This is going to still stay the same, right? This is a smaller amplitude, this is a larger amplitude, but if you just extend the amplitude, the period isn't going to change. Okay, so let's undo that. Okay, anyway, so what is dependent on the period? Well, I'll just give you the formula for it. The period here is equal to 2 pi. 2 pi is just a constant that's being multiplied, and times the square root of m over k. Now, as you can see, there's no, this is the definition for amplitude and period. So let me just box it off. Okay, so that is the definition for amplitude and period. Notice, there is no amplitude in here. Sorry, so if this is the period, this is what the period is equal to. There's no amplitude in here. No amplitude. That means it does not depend on the amplitude. Whatever the amplitude is, it doesn't matter. But it does matter on m, which is mass. How heavy it is. If it's heavier, the spring, it's harder to push around, right? Because it's heavier, so it's more sluggish to movement, so it's going to take longer, right? If the spring constant is, if the mass goes up, the period goes up, right? And if the spring constant goes down, the mass goes up, right? And if the spring constant goes up, the period goes down. And that makes sense because the spring constant is how tight the spring is, right? So if we have a tighter spring, it's going to move around faster, right? So it's going to have less period. And if there is less spring, it's going to stretch out farther and come in farther, and stretch out farther and come in farther, and
stretch out farther and come in farther, and stretch out farther and come in farther, and stretch out farther and come in farther, and stretch out farther and come in farther, and stretch out farther and come in farther, and stretch out farther and come in farther.
Okay, I think you get the point. Okay, so this is the equation for period. Let me just delete all these markings I did on it. Okay, and now I'm gonna take this equation, copy, and okay, so let's just look at one more example. Where'd it go? Okay, so if we have a mass on a spring that's from the ceiling, so this, notice, it doesn't matter, notice our equation does not have gravity in it either. So if we have this kind of this guy, it won't matter what it is because the equation does not have gravity in it. So it doesn't matter if you're doing this on Earth or on the moon or in outer space, it won't matter. It's just there's no gravity in here. So that means that there's no amplitude. There's no amplitude, and so it doesn't matter on the what the amplitude is. And there's no gravity. There's no little g in here, right? So, conclusion: the period is kind of complicated to figure out what it depends on. It is a very great it's a very great term, but it's useful to know how it got defined, or what it depends on, basically. So anyway, thanks for watching. I hope you liked this video. If you did, please give a thumbs up, subscribe, and share this video with others. Otherwise, see you at howtodostuffethan.com, and see you next time. Bye.